Hello, environmental science time. It's time for another lecture, and just to recap where we've been in this section of the course, we talked about toxicity, and then air pollution, and then water pollution, and then solid waste. I'm going to talk about hazardous waste today, which is kind of a special kind of solid waste, but it's one of the most problematic types. And it's, as you'll see, it's very bureaucratic. Just to acknowledge I'm a little bit behind and I'm working to catch up. I had some additional extra responsibilities this week and they kind of took me by surprise. So I'll work on getting my 3 lectures up and something that looks like a lab, and I hope to make myself available to anybody who needs help in making sure that this all gets completed. So, hazardous waste. So I usually start a new topic with some definitions, but finding a definition of a hazardous waste is a very, very complicated process. And we can find definitions, but there's often things about them that don't quite work very well. By not work, I don't mean they're not true. I mean they're not necessarily very useful definitions because it gets defined so many different ways. So I have a definition here. It says any solid, liquid, semi-solid, or contained gaseous material that is capable of posing a substantial present or potential hazard to human health, living organisms, or the environment when improperly treated, stored, transported, disposed of, or otherwise managed. Now, that's a very legalistic definition. It contains all the parts of something that you might want if you were going to make an argument about getting rid of a material or protecting people from a material. It's all there, but the problem is that it's so big that it basically includes everything except uncontained gases. See, solid is there, liquid is there, semi-solid is there, or contained gaseous material. So other than air pollution, which is simply released into the air, this pretty much addresses everything else. In fact, you could take that definition of hazardous and go back to our lecture on toxicity and just replace the word toxic with hazardous, and it works just fine. So it's not that useful. What happens is it turns out that that the word is used to define dangerous materials, and then we define the dangerous materials. And so what hazardous ends up meaning in most government situations is, here is the list of things that are hazardous. Here are the things that we are going to designate as hazardous. And that's where this becomes a little bit of a bureaucracy and not just a definition. In fact, it says here, failure to make a waste determination is a serious and common breach of the RCRA regulations. So right away, when we're trying to define hazardous, we are talking about an organization or an act. This is the Resource Conservation and Recovery Act. And we need to know how they are defining something that is hazardous. So we need a little bit of a history lesson. When we started this course, we started with the idea of the environmental movement getting rolling in the late 60s, early 70s because of Rachel Carson and some other things like the Earthrise photo that were really influential. And so we're going to start with our discussion of hazardous waste in 1965, in the US anyway. This is not everywhere. This is in the United States. With something called the Solid Waste Disposal Act. There were a lot of really nasty accidents happening. I'm not going to say accidents. I'm going to say some nasty health issues arising because industry was throwing dangerous stuff all over the place, into the water, into the ocean, into big holes in the ground without really thinking about it too much. This was before we had the Environmental Protection Agency. That wasn't formed until 1970, but the federal government gave a whole bunch of advice to the states. This is what you should be doing with your solid waste. This is how you should be treating the things that are especially dangerous. So already there was some government control over it, and that happened in 1965 with this Solid Waste Disposal Act. I've just put some more kind of important moments in history here. The Clean Air Act was also in 1970, same year the EPA was formed. DDT, which is one of those bioaccumulating pesticide chemicals, was banned in 1972. 1974, we had the Safe Water Drinking Act. These were all products of the EPA. So if anybody tells you we don't need the EPA, they're wrong. You tell them to come talk to me. And then in 1976, there was something developed called the Resource Conservation and Recovery Act, and you see that that is still to this day an important part of the definition of hazardous waste. And this was basically the beginning of the list. These are the things that we need to say are hazardous, and you need, if you're going to make these or use these or dispose of these in any way, you need to report it and be responsible for it. That was in 1976. So this was along with the Toxic Substances Control Act. 77, Clean Water Act. 78, we talked about chlorofluorocarbons being released in the atmosphere. That is when we started the phase out of stopping the production of those. 79, we talked about PCBs as an industrial organic chemical, and we started phasing those out in 1979. 1980, we started something called the Superfund program, which is where the EPA decided to go to places where we had already made a huge mess, dumped toxic chemicals, and contribute a whole bunch of government funds in order to clean those messes up. And this came because of a number of really bad environmental issues that were created by dumping of this hazardous waste. Then in 1984, we went back to the RCRA and made some amendments to it. Basically, the list was rewritten, and some things that had appeared and needed to be on the list were added. Some things were removed. There were loopholes and exceptions because there was a whole bunch of lobbying that was done. We have been working from that group of amendments since 1984, and I think maybe there's some call for some changes to be made to that RCRA list coming up really soon. Some other things: Pollution Prevention Act, the Federal Facilities Compliance Act, Land Disposal Program Flexibility Act. But I stopped. I didn't keep going into this millennium because I don't want to. I wanted you to be able to see where the RCA developed and how these initial steps had a big hand in it. So let's take a look at the lists that the EPA creates and applies and enforces according to this Resource Conservation and Recovery Act. Okay, so now you might notice that right away with this discussion, and certainly on the last slide, we're really just talking about the United States in the definition of this hazardous waste, and I want you to know that that's because that's what we know the most about. Other countries define it differently within their own boundaries. The UN defines it differently, and in terms of the details of what's going on in other countries, it's just so diverse that the U.S. is the only place that we can focus. It is, however, I would like to say, I believe, a success story, and I'll show you some of the evidence for that as we move along here. So what I'm showing you here is some bureaucracy with the EPA and the RCRA that shows how you can determine what's hazardous and what's not, and basically it has to do with whether or not it's on the list. If it's on the list, it's hazardous. If it's not on the list, then you don't need to treat it as hazardous. It's kind of a loophole or an exception or something we don't consider hazardous. And so they have this flow chart of questions that you need to ask. Is it solid? Because we have to start with, is it solid? If it's not solid, then the RCRA is not going to regulate it. Wow, that's kind of crazy. Is it excluded from the definition of solid waste? So did they make a loophole for it? And then it's not subject to the RCRA. Is the waste a listed or is it a listed or characteristic hazardous waste? That's what we're looking for here. And if it is, then we're going to keep going. And finally, we're going to say that everything that makes its way to this box right here, the waste is subject to RCRA Subtitle C regulation. Then if you're going to use it, you need to report it. If you're going to dispose of it, you need to report it. If you are going to even have it on site where you are doing work, you need to report it. And so as a result, there's a lot of bureaucracy and fines and a lot of of complicated legalistic arguments that are taking place. Down below this flow chart, which we would use to determine whether something is hazardous or not, there are a list of lists that the EPA puts up. They give them letters, and they have clickable places where you can go to see the extended list, and also the regulations for that particular list will be available there. So we need to determine if it's a listed item, and we need to determine if it's listed, what is it about it that's dangerous, how much of it can we store, what do we need to do in order to dispose of it. There's a lot of bureaucracy, and hazardous waste is very expensive. It's expensive because you can be fined. It's expensive because you can be be required to treat it properly and pay some other company to do that. So this is really important. It's so expensive, and I think I say this in a later slide, that it becomes secretive. And a lot of people and a lot of companies will dispose of hazardous waste in a secretive way so that the expenses don't become part of their business operation. That's a big problem with hazardous waste. So history and bureaucracy were some pretty long slides there. It took us a while to get through those. This is a little bit simpler, at least for me, because it's like, oh, well, now I can determine whether this is true or not. So there are 4 groups of hazardous materials as defined by the EPA and the RCRA. These are materials that are burnable, that are corrosive, that are reactive, or are toxic. And we have to have labels. Anytime we're transporting these materials, anytime we're storing them, anytime we're disposing of them, they have to be labeled with these special warning labels so that everybody can know what category this material is in. Actually, I'm showing 4 labels here, but there are dozens of them for, fine variations of these hazardous materials. And then there's some pictures up here for what it looks like if something is ignitable and corrosive and toxic and reactive. Reactive is one of the worst because that means it can explode. Just because it's ignitable doesn't mean it's explosive. So if it's burnable, it could be hazardous, but if it is reactive, it could be explosive. That's a big problem. Anyway, one of the things that you might want to notice is that there are some numbers associated with these categories. D001 is one number. D002 is one number. D003 is one number. But D004 through D043 is a lot of numbers. And so what I want you to know is that even though there's 4 categories, one of them is a huge category and needs all these subcategories associated with it. That is toxicity. And here is a little bit more detailed list about what it means to be toxic and how we might divide these things up. But you know what? We already did a lecture on that. So all we need to know is how do we legally define these things. And it says here, if it has been shown to be fatal in humans in low doses, bam, it's toxic. But if we don't know whether or not it's fatal to humans in low doses, then we might test it on rats. And it says, if the oral LD50 in rats is less than 50 milligrams per kilogram, well, we know about how to do those tests. So we need to do these tests to define whether something is dangerous or not. Or if they do an LD50 with inhalation in rats, 200 milligrams per kilogram. Touching the skin of a rat, 200 milligrams per kilogram. So we're defining these, and clearly rats are very important in determining whether something is dangerous for humans or not. And also it says that it is capable of causing or significantly contributing to an increase in serious, irreversible, or incapacitating reversible illness. I want to draw your attention back to a couple of terms that I defined in that toxicity lecture, that pollution lecture. And that was acute exposure versus chronic exposure. The issue is when there is an acute exposure to something and it has an immediate impact, it's very easy to say, you know what, we need to call that hazardous. But what happens when somebody is exposed to small doses of something over very long periods of time, and so the symptoms they're having, the health issues they're having, may be a bit disconnected from the exposure that they were having. That's when this becomes difficult, because all these LD50s, that's all about acute exposure. And we have a much more difficult time determining hazardous wastes that cause chronic exposure problems, and we're not doing a very good job of that. So these could clearly be expanded in the future. Anyway, so you need to know these 4 groups, and you need to know that toxicity is the biggest one, and that it's mostly about acute exposure, not chronic exposure. Okay, so as we have done quite a bit in this section of the course, we're going to divide up right away by waste that is from factories and from industrial applications versus waste that's from municipal, residential, small business things. So this slide here deals with industrial hazardous waste. I just wanted to give you some examples of things that might be released at that higher level. And we can see our categories up here, and in the list, these are 2 different lists, they're not related to each other. But we see corrosive materials. Here are our CFCs. Those are reactive. Cyanides are toxic and reactive. Dioxins are toxic and reactive. Explosives are ignitable and reactive. Heavy metals are toxic and reactive. We could just keep going down through here. And there's even some scary things down below, like radioactive waste, which we've talked about, and nerve gas. You might think, what? Who's releasing nerve gas into the environment? Well, pesticides sometimes are using products like that in military applications. So anyway, lots of examples of things that need to be regulated, and if you're going to store them, or if you're going to dispose of them, or if you're going to use them in any way in a process, that needs to be reported according to the EPA. Over here on the right, we have things that might actually seem a little bit less dangerous, like batteries and insulation, but these have chemicals in them that need to be tracked. Asbestos in insulation material, paints, pesticides, any kind of solvent, mercury lamps, fluorescent light bulbs, which have chemicals inside them that make them toxic. They need to be, especially if you're replacing a lot of them at a place like Columbia College, they need to be, when they're not being used anymore, stored aside and disposed of in the proper way when you get a large enough volume of them. And you even need permission on how to store them properly. Thermostats, switches, gauges, transformers, capacitors, a lot of electrical things. Air conditioners, any kind of cooling system, because the refrigerant in there is often going to be kind of associated with this CFC problem that we've created. Anyway, lots of examples and things all around us all the time within our homes and within the companies that we might function in that we might want to draw attention to. And here's a slide with a similar list, but it's about household hazardous waste. And there's a bunch of things here that you might have around your house right now, in your garage right now. If you have a pool, you got chlorine. If you clean your house, you've got cleaners. Dyes, glues, fluorescent light bulbs I mentioned before, antifreeze for your car, different types of oils, pesticides, herbicides, weed killer or insect killer. Anyway, these are around everywhere. The issue is not, oh my gosh, it's in my house, so it's dangerous. The issue is, what do you do with it when you're done with it? And by done, I don't mean that it ran out. I mean, what do you do with the container it was in? Because it's contaminated. Or maybe if you didn't use it all and there's some sloshing around in there, what do you do with that? And the problem is a lot of people, a lot of times, and even though it says it on the label, you shouldn't, a lot of people just take it and toss it right in the trash. And then it goes right into the landfill, and then this is hazardous waste right into the environment. So we can't just point at industry and say, what a terrible job you've done, because we're doing a terrible job too. Read the labels when you're buying something, and if you really don't think that you want that stuff around your house, or if you really don't think it's going to be easy to pay the price to dispose of it properly, don't buy it, because that will bring market pressure to the industries that are creating those products. Okay, so in order to protect ourselves from the industries that are using hazardous materials and the things that are in our household that might get out into the environment, we have regulations. And our regulations are built from the EPA and from this Resource Conservation and Recovery Act that was created in the early 70s, 76, I think, and then updated in 84. Anyway, according to those regulations, all management, storage, treatment, and emergency plans need to be clearly stated and followed if any of these materials are going to be used in any kind of situation. Maybe not the household situation, because that's very small amounts, and so there are cutoffs in terms of the amount. If you wanted to have a 50-gallon drum of pesticide in your house, you probably would want to think about the RCRA regulations. The issue is this, and I think I mentioned this before. Producing hazardous waste is expensive because storing it properly, disposing of it properly, using it properly requires people to be paid. It requires procedures to be followed. It requires equipment to be bought. So it's expensive, and as a result, it becomes secretive. So that there is kind of, especially at the industrial level, kind of a black market for buying chemicals and getting rid of chemicals without ever having to report them. I can't find a picture of chemicals being disposed of secretively, but I have a picture here of somebody who dumped a bunch of garbage in the woods or wherever this, in a meadow. I see some tires in there. I see a bucket that may have been a bucket of paint. These are considered hazardous waste, and you can't just throw them into a landfill. You have to pay to have them dealt with properly, and so sometimes it's cheaper to just go somewhere where nobody's watching and dump it. That happens both on the household level and at the industrial level. Now, if we're doing it right, and the right way is the expensive way, what are we doing with this waste? Well, there's a lot of different options that are available, and I've got a list here of physical methods and chemical methods that might be used to make something less hazardous. Most of these techniques, however, are going to really just be concentrating the problem and then releasing other pollutants that aren't considered hazardous. So they're not necessarily going to, be something that just erases the issue from the start. So there's a lot of encouragement to not deal with hazardous waste, but there's a lot of industries that don't have any choice about that. So we can dry liquids, we can let them evaporate. If you have some solvents, leave the can open, let it evaporate into the air. We can screen large materials from smaller materials. We can grind stuff up. Drying and evaporating are kind of the same thing. We can allow solids to sink out of a liquid and remove those solids. We can filter material. We can fix it, which means to add something that takes it from a liquid state to a solid state, so that then that solid can be dealt with in a way that's less transportable. Chemical methods include oxidation, which is burning, okay? Reduction, which is usually adding an acid. Neutralizing, which is maybe adding a base to get rid of the acid. And then hydrolysis, which is a fancy word for adding a whole bunch of water and allowing the water to react with it. So it's a nice list. Most of what happens is either burying or burning. Okay, so before we bury it or burn it, we're probably going to do one of these things to make it a little bit less toxic. So I've got a cartoon down below here that's showing some waste generation that's happening. Let's see. I can barely read it, but it says a lawn care company is using dangerous chemicals. A paint shop is using dangerous chemicals. A dry cleaner is using dangerous chemicals. And somebody painting their house is using dangerous chemicals. All of those are true. So what do we have to do? We have to get those to a facility that gathers them up, puts them into the right transport, and takes them somewhere where they can be dealt with. They will either recycle them or treat them and put them in barrels or dump them in the landfill, and maybe they'll be doing all of those a little bit. And hopefully before they're dumped into the landfill, they're treated in some type of proper way. And you notice that there are some big drums there for the treatment, because after something's treated, it becomes a more concentrated waste. Then we're going to put it into a drum and bury it somewhere. Not just the landfill, but bury it somewhere. Up above here, I have another process that's taking us around, excuse me, in a cycle. But this one focuses on not the burial side of things, but the burning side of things. So this one down here is focused on burial, and this one up here is focused on burning. And apparently 16 to 10 hours of sitting in a very high temperature furnace, and then collecting the ash and driving that somewhere to dump the ash in a landfill is a standard way of getting rid of some of these wastes. So burning or burying, even though there's a big list here, that's how we're getting rid of it. So at this point, I should not need to tell you that burning stuff and burying stuff is not really getting rid of the problem. Burning it is releasing a lot of air pollution, and burying it is just, especially after it's been treated, is taking the most concentrated, most toxic parts of what's left over and then getting it away from us temporarily, because burying doesn't solve the problem forever. We've seen the burial issue with landfill. We've seen the burial issue with nuclear waste. And this is just a kind of a generic hazardous waste landfill site, which has some of the same characteristics we talked about before. It's got plastic liners. It's got pipes maybe to remove leachate. And then it's got a cap of organic material, soil, and vegetation that might be growing. But somewhere in the middle, there are big barrels full of really toxic material that hopefully won't ever be exposed to an earthquake or a natural disaster that might cause them to spill out all at once. So, but this is pretty typical, burning or burying. So there are some things that burning and burying doesn't work for, and so they're very expensive to get rid of. And so industry and even municipalities and certainly governments have come up with a third option that can be used to deal with some of our hazardous waste. And this waste is what we refer to as e-waste, and it's becoming more and more of an issue because we are using more and more electronics in our lives. And even if you take your used up electronics that don't function anymore to a center where they put them all together, they could be ending up in a waste stream that's not being dealt with in the most productive way. So the way that we're dealing with it is that we are often exporting these materials. Other less developed countries, other weaker economies are getting paid. We're paying them to take our waste. And as a result, because they don't have the government infrastructure to really take care of it properly, they're just taking the money, they're taking the waste, and they're allowing the citizens to be part of the process of picking things apart, getting metals out of the material, getting things like mercury switches out of the material, lots of hazardous material. So this is an article from the United Nations saying that toxic e-waste is being dumped in poor nations, and that's been going on for quite some time actually. There's not any international regulation of it, but there may be in the future. The irony is that the regulation may not have as much to do with the nasty toxic metals as it does with the plastics, because plastics are closer and closer and closer to being considered a hazardous waste. The moment that we do that with some type of international agreement, most of our electronics are made of plastic with all of the other chemicals and metals and things inside. So they will be regulated according to hazardous waste. Right now they're not. They're being eliminated, but it doesn't really cost industry very much to do that. In fact, it's cheaper to pay other countries to take it than it is to actually deal with it in the most sanitary and secure way. So in addition to getting rid of hazardous materials that are being used today, tracking them, managing them, storing them properly, paying to get them disposed of and buried or burned or whatever it is we're going to do with them, there are a lot of places where we didn't do a very good job, And so I mentioned in the history that I went through that at some point the EPA defined what's called the Superfund program. That doesn't sound like a terrible thing. Superfund, yeah, send me the money. Well, if you're getting Superfund money in your state, it's because there's a pretty big problem that was created before the regulations were really being enforced. Some of these were after the regulations were enforced, but and so some of the Superfund project is supported by fines and industry standards that need to be enforced. So all over the United States, because the EPA is only responsible for the United States, not for the world, all over the United States, there are places that have been identified as Superfund sites where posted in those sites are signage that say, no, you cannot come in here. There are hazardous substances here, and they're not just present in the material laying on the ground, they're present in the soil, they're present in the air around these sites. These are problems that are either being isolated long-term or being attempted to be cleaned up. And we have some sites like that right here in this part of South Carolina. Actually, I'm showing that there are 1,317 spots that are designated Superfund, EPA Superfund sites. And here's a little map of South Carolina showing that even right in the Columbia area, we have some sites like that. A lot of them are associated with places where there used to be factories, places where there used to be illegal dumping sites, places where there used to be dry cleaners because those the carbon tetrachlorides end up in the soils. Anyway, this is an ongoing thing, and it's kind of a warning sign of the fact that we didn't get things regulated and managed quite soon enough, because we're still dealing with problems from the past. I'm also going to put up a video that I'd like you to watch that summarizes some of the major Superfund sites that'll go along with this particular lecture. So I'm wrapping up here, and as I finish this up, I want to talk about something that's actually not a hazardous waste, but it maybe will be, and it maybe should be, and that is plastics. And that's just such a touchy subject and such a huge subject that I'm not even sure how to deal with it, except to show you that there's a lot of people, including some very smart scientists, including the UN, including news organizations, environmental organizations, that are saying plastics should be considered hazardous because they meet all the requirements for hazardous material for the United States and for a number of other countries. And we're not dealing with them in a way that that regulates them properly, and as a result, they are getting everywhere, and they don't break down. So they're something we're going to have to be dealing with for a very long time into the future. We see a lot of pictures of plastics on beaches because they tend to accumulate there. They have an impact on organisms in the ocean. So the oceans are a big issue. But as plastics break down, become what we call microplastics, smaller pieces, they end up in the soil. They're going to end up being absorbed by organisms. We're going to end up inhaling and ingesting them in the future, because obviously if a big chunk of plastic is sitting on the ground, we can pick it up, put it into a landfill, cap it off. But if it's out in the environment breaking up into smaller pieces, it's going to end up in all of the materials that we are exchanging with the environment around us. So this is my little homage to maybe plastics should be considered hazardous so that we can regulate them better. So plastics are a problem, and they're not going away. If they are put in an insecure landfill or dumped in the woods or someplace where they're allowed to be transported around the environment, eventually they're going to make their way to low topography. Gravity does that. Low topography means rivers. Rivers go to the ocean. So a lot of these plastics are ending up in the ocean. This is a particularly nasty situation, but that doesn't mean that that they're not getting there in a lot of less obvious states. Even when we can't see them, they're getting there. one of the reasons I like this picture is that I can scan that and see some of the plastics that I use. I see these foam containers that are associated with quick one meal. We got plastic bags, we got potato chips and snacks and cookies, we got straws, we've got, I mean, this is just all plastic. They don't sink naturally. They're either neutrally buoyant or they float. And so as a result, they end up in situations like this. It ends up in the ocean, and then we can find evidence of it because it concentrates in some places. One of the reasons it concentrates is because once it's in the ocean, it can move around with currents, and we know a few things about currents in the ocean. We know that for instance, here in the North Pacific, that there is a gyre that goes around the ocean in this direction. And we also know that things in the northern hemisphere, according to the Coriolis acceleration, tend to be deflected to the right. And deflected to the right, if we're going around in this circle, means that everything is being driven in towards the center. Things that are moving are being pushed toward the center of the ocean. And so we end up with this nasty pile of plastic garbage called the Eastern Pacific Garbage Patch. Why is it in the Eastern Pacific? Well, it just so happens that because of the spin of the Earth, what's being pushed to the center ends up also being pushed over to the east. It's not like it's a floating island of trash. It's just a place where you can go in the middle of the ocean. And by the middle of the ocean, I mean it could take you hours to get out to where this is. Where there's just a lot of this stuff that ends up all concentrated in one area. It's a major problem for marine organisms, and it's not going away. And I've seen a lot of creative blogging and light news stories about ways that people have proposed to clean this up. It's way too big for that, all right? It would be recreated before you would even remove a tiny fraction of it. So anyway, and this is also, by the way, happening in the Atlantic, and it's also happening in some of the areas of the Southern Hemisphere. That's what we're looking at here. This is a big problem, clearly a problem for the organisms that are trying to exist here. One thing I want to say about it, before you think about it being right next to North America and seems to be associated with the United States, think again. And I think I mentioned to you that we do a pretty good job with our trash compared to other countries, and I've got some data to support that. So here's a complicated diagram, and I put it in here to show you some aspects of the scale of what we're talking about and where these things are ending up. I know you can't read it. I'm going to kind of walk you through it. First of all, there are three graphs, and the first one is called shoreline, the second one is called coastal, and the third one is called offshore. So these are three areas associated with the ocean where plastics are ending up. The red bars are what we call microplastics, which is smaller than half a centimeter, a piece of plastic smaller than half a centimeter. The blue bars are what we call macroplastics, which are larger than half a centimeter. And the bars are in sets that represent decades. This is probably the thing that you can't read most of all. This is the 1950s, 60s, 70s, 80s, 90s, the 2000s, and up through 2015, and so that's what we're looking at here. Just before you go, look, it's headed in the right direction, it's going down. That's because that last bar is only containing 5 years instead of 10 years, because this was developed from data that were collected in 2015. Anyway, so it looks like most of it's ending up on the shoreline or offshore, not in the coastal environment, which is when we get in a boat and go out and say, hey, let's go check. We're not going to see as much in the coastal environment, either on the shore or offshore. And that's those, those places where the garbage is accumulating in the middle of the oceans. We are looking at some especially huge increases in macroplastics in the coastal environment. This is bottles and things that are making their way to the ocean, just like what we just saw. And this is, by the way, this is in tons. Actually, it is in, it's in tons of material. Unfortunately, they chose not to include a scale on these diagrams. But I can see that the highest numbers are in the megatons. There are, for instance, 40 megatons of microplastics have been found on the shorelines, and 82 megatons have been of macroplastics have been found on the shoreline. Anyway, what I want you to see is that it seems like microplastics are maybe on their way down a little bit. Those are the red bars. Macroplastics are continuing to increase. The only reason microplastics are on the decrease is because we've started to make plastics tougher so they don't fall apart as quickly, and also because industries are being regulated. Industries back in the 80s, 70s, and 80s were dumping microplastics because they couldn't use them, couldn't figure out a way to use them. They became contaminated, and so they would just dump them into the environment. So regulations and tougher plastics are making microplastics a little bit less of an issue, but macroplastics are seriously on the rise. Don't be fooled by this last bar here and this last bar here, because those only represent 5 years of data. So pretty much just double them and see how far those are going to be going. Big problems, plastics, big problems. So here are some results from that analysis, that 2015 analysis, plus an additional one here talking about where the plastics are coming from. And there's two ways to answer that question. Where are the plastics coming from? First of all, there's the geographic answer to that, and then there's the answer of what are the products, what is producing these plastics. So let me draw your attention first of all to this diagram in the upper right, where we are basically looking at what's floating in the ocean, what's found floating in the ocean, and people who did this analysis just counted them. They just counted them and tried to figure out where all the trash is coming from. So we have plastic candy wrappers, plastic bottles, plastic bags, plastic caps, plastic flatware, and plastic straws. All of those are plastics that are floating around in the ocean. And those plastic bags include packaging bags as well. So clearly a big issue. The other things we find here are cigarette butts and glass bottles and metal cans and paper bags, which are an issue, but those are more recyclable and more biodegradable in some ways. The other way of looking at that question of where the plastic's coming from is where they're coming from geographically, and this is from that 2015 analysis, listing some countries and saying this is where most of this stuff is getting in the ocean. Some of these countries are just dumping their trash into the ocean because they don't have the resources to develop proper landfills. And if you're going to dump your trash into the ocean, and there's no way that's regulated internationally, it's your ocean, you can dump it. It's just that when it travels out, that becomes a bigger problem. So if that's going to happen, then clearly it's going to be a bigger problem for some countries than others. And we start with China and Indonesia and the Philippines. Clearly we're over in the Western Pacific side of things. And then finally we make our way to Africa and India and South America. And what I want to show you is that this is not free pass, but this is showing the data from 2015 illustrating that the U.S. is contributing less to the plastic problem in the oceans. This is just in the oceans. And the light blue stack on top of that is what is supposed to be contributed by 2025. And the U.S. has done a much better job at regulating those things, even though we still find plastics around. Think about how much worse it could be. And that picture I showed you where all those plastics were right there at the shore, that's from some of these countries that it's much, much, much worse. It's just, it happens to be transportable, which is a bit of a problem for the rest of the world. Okay, last slide. And I know, once again, I know that you can't read this. It's crazy small. I just really want to draw your attention to a few aspects of it. This is a picture, kind of an infographic, that runs us through the hidden cost of plastics on this planet. And that's kind of where we started in environmental science, was trying to expose some of the hidden costs of environmental issues. The health costs of plastics. things that we might not have even mentioned in this lecture that that create health issues, not necessarily by having them pile up around us, but just by being exposed to them all the time. So there are 4 categories of direct exposure to the plastics problem here in this diagram. There is extraction and transport, and that is plastics are made, I don't know if you knew this, but plastics are made from oil, from petroleum products. So a whole bunch of the oil that we pull up out of the earth as a fossil fuel, we don't burn it to get energy. We actually use it to make plastics. So through the process of extracting those petroleums and through the process of transporting those petroleums, there is human exposure. It says here that it is inhalation and ingestion exposure. Then through the refining and manufacture process of the plastics, there is inhalation, ingestion, and skin contact, and that creates problems. By the way, there's also lists below these pictures of this person taking in toxins that list the ways that there could be health issues. Then there's consumer use, and just using plastics can sometimes be dangerous. And if you're not with me on that, then consider the BPA issue that we just went through, where they had to change the nature of the plastics that were being produced because suddenly there was a big to-do about some toxic chemicals that were in those plastics. And I see tires here, and I see maybe vinyl furniture covering, plastic bottles, toys. A lot of these things have toxic materials that can create chronic exposure issues. And then finally, the last one is waste management, which is really what we've been talking about, the hazardous waste. I'm just kind of expanding this issue of plastics beyond just the waste. And with the waste, we have skin contact, we have inhalation and ingestion, and then we have kind of a special line that comes down here to what might be exposure to microplastics in the future. Because as these particles get smaller and smaller and smaller, they become less visible to us. We may even be engaging in the practices of grinding them up and then disposing of them in the environment. This is showing that we can expect our ingestion of plastics through our food and our inhalation of plastics through the air we breathe and our ingestion of plastics through the water we drink to increase and increase. This is clearly a chronic exposure issue. So when I say that it's a good idea that we might be considering plastics as a hazardous waste, it's not just talking about the exposure we're having now. It's talking about the exposure of people in the future. We don't often do a very good job of considering the environmental issues that might have a role in the health of the people of the future. And so with plastics, that's something that we might be able to think about now and have a stronger hand in that as we move forward. Okay, so that's hazardous waste done there. Now I got to run off and start a lecture on climate change. And please remember that we only have, after this, we only have 1 week left and then an exam. So I will probably put up one more lab for you to do, hopefully by tonight or soon, because if I gave you one next week, then I wouldn't be able to expect you to get it done. And of course, we do want some time to prepare for our exam. So one more lab, a couple of lectures up tonight, and maybe 2 lectures next week. I can't go 3 lectures because I think I need to leave some time for review and for my own sanity. So I hope everything's going okay and that we're getting this done. Please be in contact with me if I can do anything to help, and don't touch your face.